Hey y'all, welcome back. Today we are going to wrap up our unit previewing some of the concepts that you'll be engaging with next year in geometry. So in our last lesson, we introduced this idea of an angle and also went through some vocabulary terms to describe certain kinds of angles. Today we're going to get a little bit deeper into that. We're going to look at the relationships that certain angles have and just go through a little bit more vocabulary. You'll use all of this next year, and there's a lot more to come. But hopefully after today and after the end of this unit, you walk away with at least a little bit of an idea of what to expect next year. So let's jump into the notes and let's finish this off. What we've got here is a list of terms that describe different relationships between angles. So let's just start here at the top. Complementary angles are angles whose measure add up to 90 degrees. So the definition here being two positive angles. We're off to a good start here, y'all. Okay, all right. One last try, third time's a charm here. Two positive angles whose measures have a sum of 90 degrees. So this can be any two angle measures that add up to 90. So let me show you a quick example here. Let's say we had a real kind of small angle here. So this one looks like, we'll just say, I'm not going to measure this, but let's just say this one's 20 degrees. And then let's say we've got another angle measure that measures 70 degrees. So something a little closer to this. So if you have two angle measures whose sum is 90, and in this case 20 plus 70 is 90, you would call these two angles complementary. So if I said, what's the complement of an angle measure of 20 degrees, you would say 70 degrees. Supplementary angles have a very similar definition here, except instead of adding up to 90 degrees, they add up to 180 degrees. So two positive angles whose measures have a sum of 180 degrees. So as long as the two angle measures add up to 180, you know that they're supplementary. So like for instance, let's say I had one that was a little bit above 90, so I've got this obtuse angle. Oh, where'd that go? And I'm just going to label this with, let's say, 115 degrees. Oh, I just want the degree here. And so if I wanted the supplement to this angle measure, I would need another angle that would add up to 180. So what plus 115 equals 180? That would be 65. So if I had another angle measure that was 65 degrees, these two would be supplements. So these are supplementary angles. So again, these words are describing the relationship between two specific types of angle measures. So complementary, they add up to 90. Supplementary, they add up to 180. Adjacent angles, the definition here has nothing to do with what they add up to. Instead, they have to share a common side and share a vertex. So two angles that share a side and a vertex. Okay, so what that means is like they're not going to be separated like this. They will share a side. So you might have, an angle that looks like this, and then the other one, might be coming over here somewhere. So you've got two angles that share this vertex. So the vertex being right here. Again, the vertex, remember, is this little corner point where the two rays meet each other. So in this case down here with these adjacent angles, you can see they have the same vertex and they share a side here. So it doesn't really matter what they measure here. As long as they share a side and a vertex, you're going to call them adjacent angles. A linear pair is what you get when you sort of mix the supplementary angles with the adjacent angles. So if you have adjacent angles, so they share a vertex and a side, whose sum is 180, you have what is known as a linear pair. And the reason why it's called a linear pair is because when you sketch this out, the only way for this to really work is if the sides that they do not share lie along a line. So you have this common side here, and then the other two sides form a line. So that's why it's called a linear pair. Okay, key word here being line. Okay, so linear pair is what you get when you mix supplementary and adjacent angles. Okay, so there are two positive angles whose measure, or here, we can even make this a little bit more efficient. Two supplementary adjacent angles. There we go. That is not how you spell adjacent, my bad. Got an extra A somewhere in there. Okay, so two supplementary, meaning they add up to 180, and adjacent angles, meaning they share a side. Okay, so in this case, these would be exactly that. They share a vertex, they share a side, and the two other sides form a line, which is why you call them a linear pair, so they should add up to 180. Recall that one full revolution is 360, so half a revolution would be 180 degrees. A quarter of a revolution is 90. So those are kind of your important angle measures just to recall off the top of your head. Now vertical angles are what you get when you get like two crossing lines. Okay, so let's say I had a line that does this and a line that does that. What I've formed here are four angle measures, right? Are four angles. I've got this angle up here, I've got an angle over here, an angle down here, and an angle down here, or over here to the right. So what I have is two pairs of vertical angles. So let's define what a vertical angle is, or what a pair of vertical angles are. They're angles whose sides form two pairs of opposite rays. Okay, so basically what I'm saying is that let's name these angle measures to make it a little easier to describe. So let's say this is angle, here I'll use a different color. Here's angle 1, here's angle 2, here's angle 3, and here's angle 4 over here. Let's move this over. So let me grab it. There we go. So in this case, you would say that angle, there we go, angle 1 and angle 3 are vertical pairs, or vertical angles rather. And then also you've got this other pair, 4 and 2. Okay, so angle 2 and angle 4. Both of these are examples of vertical angles. So basically they're these opposite angles that you get when you cross two lines like this. And something that we'll talk about as we go a little forward, well actually that's what it's going to ask us down here, is what's true about these vertical angles is that they're congruent. Okay, so 1 and 3, angle 1 and angle 3 are vertical angles. And so are 2 and 4. All right, and we'll kind of go through some more examples there just to kind of solidify that, but that's what vertical angles mean. So just to kind of wrap this up, what must be true about the sum of the measures in a linear pair of angles? Well, in a linear pair, we said they're supplementary. Okay, so we kind of already established that, but they have to add up to 180. Okay, so their sum is 180 degrees. What must be true about the measures of a pair of vertical angles? So like, what's the relationship between 1 and 3? What's the relationship between 4 and 2? Well, they're congruent. Okay, so vertical angles, or I should say the measure of vertical angles is equal. Also, you can also say just plainly, the vertical angles are congruent. Let's see, I think my grammar is a little jacked up here. The measures of vertical angles are equal. Let's see, that probably sounds a little better. All right, so let's clean that up a little bit. There we go, make that fit in the box. So that's what's got to be true. Okay, so like the measure of angle 4 and angle 2 up here are equal, and so you would say angle 2 and angle 4 are congruent. So you say equal when you're talking about actual numerical values, and you say congruent when you're talking about the object itself. So just to kind of go over these terms a little bit more, if I say what's the complement of 60 degrees, and if you can't remember, just go back up here to your notes. You say, okay, well, complementary angles add up to 90. So what's the complement of 60 degrees? We would say 30 degrees. What's the supplement of 20 degrees? Well, supplementary angles add up to 180. So what angle measure would sum with 20 degrees to give you 180? That would be 160. So you just want to know the difference between complementary, meaning they add up to 90, and supplementary, meaning they add up to 180. So let's go down here to this next little example. Just kind of, this is all. So this is pretty much all the vocabulary you're going to need for today. We're just going to answer a bunch of questions that have to do with these terms. So let's start the examples. This first one says, so what we're doing here is just kind of identifying the complementary, supplementary, and adjacent angles. And so let's start with complementary angles. So we're looking for two angle measures that add up to 90 degrees. So if you want to speed things up a little bit, feel free to bust out your calculator here. You probably don't need it, but it doesn't. That's not what's going on here. I got the wrong thing. Well, that's strange. It's not coming up. Hold up. There we go. Okay, so we've got this calculator now. So we're just going to basically test some of these out. So we're looking for two that add up to 90. Okay, so if you're thinking, okay, well 28 plus 72, that looks pretty good. You say, okay, it's 28 plus 72. Oh, that's 100. That's not 90, so that's not going to work. So maybe 28 plus 62. That's probably going to work a little nicer because we're 10 degrees off here. So 28 plus 62 just to test it. And yeah, we do get 90, so we can call those two angle measures complementary. So the way to type that is we're going to say, okay, so what are the complementary angles? So it's going to be the 28 and the 62. So the way we're going to name the 28 angle is going to be ABC. Although you could name it CBA. You could name it either way. Just make sure that that vertex is in the middle. And then the 62, we could either call it FEG or GEF. Again, just make sure the vertex is in the middle. So I'm just going to go in alphabetical order. A, B, C. And let's see, the other one was angle, what was it? FEG. So yeah, we've got these two angle measures. I'm going to pull this together and make this look a little nicer. Okay, well, it doesn't want to let me. There we go. Okay, so so those are complementary angles, and we also want supplementary angles. So we know that supplementary angles add up to 180, and this is not going to be our answer. I'm just kind of getting this template ready so I don't have to remake all those text boxes. But okay, so we got to find two that add up to 180. So complementary angles, remember, 90 degrees. Okay, sum is 90. Supplementary, they add up to 180. Adjacent means they're next to, they share a side. Okay, so they share a side. Okay, so just want to kind of make sure we understand what these terms mean. Okay, so maybe I should be even a little bit more specific here. Add up to 180, and or 90 rather. Add up to 180 for the supplementary. So as you're looking through these, for examples, I want to be real clear how I'm picking these. So two angle measures that add up to 180. I can see I'm probably going to be right here. Let's see if this works. 108 plus 62. Just want to double check that in the calculator. 108 plus, actually I don't think that is going to work. That's only going to be 170. Yeah, so it's good to basically test this out as we go. So it looks like 108 plus 72 is going to be our winner here. Yeah, so there's 180. So so we're looking for the 108 and the 72. So the 108 we could either call DEG or we could call it GED. I just like going in alphabetical order, but it doesn't really matter. Just again, make sure that your vertex is in the middle. Make sure this E is the middle letter. So I'll just go in alphabetical order here. DEG, okay, is one of them. And then the other one is the 72, which is this one down over here, which is We could call it HJK or KJH. So I'm just going to call it HJK. Adjacent angles share a side, and so there's really only one option here that you can see visually, and that's this DEG and then also FEG. So they both share this EG side. Okay, so that's how we're going to know that they're adjacent. So let's go ahead and name these two. There we go. So let's see, so DEG, okay, so we already got that one. That's nice. Don't have to change anything there. And then the next one, FEG. And you could call it GEF, doesn't, again, kind of saying this over and over again. Just make sure you get that vertex in the middle and you'll be good. So FEG would be the other angle measure. So these are your pairs. We got a complementary angle, supplementary, and adjacent angles. Down here, we're talking about linear pairs and vertical angles. So we're going to have, look at this diagram, we're going to have a ton of both of these. This is going to take a little bit of time to write this out. We don't need the calculator here because we're not actually measuring any of the angle measures. So linear pairs, just to kind of go back up here, mean that you have two supplementary adjacent angles. So you can see we've got a ton of those here, like 4 and 3 share a side, and they clearly add up to 180 because these two rays lie along the side. Or lie along the line, rather. So 4 and 3 are going to be linear pairs, 8 and 7, 5 and 6, 1 and 2, and you even have 4 other pairs hidden in here because, like for instance, 1 and 4 are a linear pair along this line, 2 and 3, 5 and 8, 6 and 7. So we've got a ton of examples of linear pairs here. So just to, I don't want this to get too cluttered, so what I'm going to do is I'm going to draw a line here separating out my linear pairs from my vertical angles just to make it easier to read. Okay, so my linear pairs are going to be, let's start just, well, I guess we could just go kind of in, well, I've kind of like going by the picture. I was debating whether or not to go in numerical order or just like kind of how you read it on here, and I think I like the reading it better. So let's go like from left to right here. So we've got angle 4 and angle 3. Okay, so that's a linear pair. Then we also have 8 and 7. So that's another one. And then we've got 1 and 2. And then we've got 5 and 6. Now again, those aren't the only ones. Those are just the ones that horizontal line is sort of creating. We also have 4 more sets of linear pairs because we can group 1 and 4. Like these two angle measures should add up to 180. These two rays, these two sides, create a line, so we know they add up to 180. So let's go ahead and include these in our linear pairs: 1 and 4, 2 and 3, 5 and 8. Forgot an angle symbol over here. And then finally 6 and 7. Whew, that's a lot. Okay, so those are all the linear pairs. And then vertical angles are a little bit different. So just kind of going back up here, remember vertical angles are these angles whose sides form 2 pairs of opposite rays. So when you have like 2 lines that cross, these opposite angles are considered vertical angles. So like 1 and 3, 4 and 2. So if I'm looking at what I've got down here, I can see like a pair of vertical angles would be like 1 and 3, 4 and 2. It's almost like the same diagram I have up here actually. So let's start with those. I'm just going to copy one of these to save some typing here. So yeah, 1, oh, didn't copy anything. All right, let's try that again. 1 and 3 is going to be a pair. 2 and 4 is going to be a pair. So those are the 2 pairs of vertical angles that I get for like this line crossing this line. But then I also get 2 pairs of vertical angles over here from this line crossing this line. So we get 5 and 7. And we get 6 and 8. So we're just defining these. I mean, we're just really making sure that you understand what these terms mean. You'll have some more practice, I'm sure, shortly, but I just want to make sure you understand what complementary, supplementary, adjacent, linear, and vertical angles mean. So that's how. So these are. I think that goes through. Is that all of them? Yeah. Okay. So that what we've gone through here are just examples where we're naming angle measure pairs based on their relationship. So if they add up to 90 or 180, if they share a side, if they lie along a line, or if they're across each other. So there we go. Okay. Now what we're going to do is just look at some example problems where we can actually use algebra to solve for them. That's kind of where we're going with this. So you can see once we get to number 4, we're going to have to set up an equation and solve it and do that sort of thing. All right, number 3. Use the figure to the right to answer the following. Do any of the numbered angles form a linear pair, and which angles are vertical angles? So we do have, actually, do we have a linear pair here? I don't think we do, because look, like any given line is going to be split up amongst 3 angles. There's no 2 angles that lie on a line next to each other. So yeah, we're kind of out of luck there. There's no linear pair here. Okay, so like you could say like 1, 2, and 3 add up to 180, but not just 1 and 2, or 2 and 3, or 4 and 5, or 6 and 5. Their rays don't form a line. Okay, when you have a linear pair, you're only allowed to group 2 of them, not 3. So if the question is, do any of the numbered angles in the figure form a linear pair? No, a linear pair can only have 2 angle measures. Okay. So that's the answer to the first question. The second question is, which angles are vertical angles? Okay, so now we actually do have some vertical angles here, because we can see, like, for instance, this line right here, I'm showing you, and this line cross to make this pair of vertical angles with 1 and 4. Now, the other, the other one right there, 2, 3, 5, and 6, you can't say that they're a vertical angles. They have to be directly across from each other. So we got basically 3 pairs here. We've got 1 and 4, 2 and 5, and then finally 6 and 3. Okay, so the vertical angles, there's going to be 3 of them, 3 pairs, and so what I'm going to do is just actually steal 3 of these from up here and then change the numbers to be what they need to be. So like 1 and 4 is going to be a pair of vertical angles. 2 and 5 is going to be a pair. And then the last one is going to be 3 and 6. Okay. All right. So let's do some algebra here, y'all. I mean, this is algebra after all. We're not in geometry quite yet. But again, we're just kind of previewing these terms so that when you hear them next year, it won't be the first time you've heard of any of these terms. Okay, so let's look at number 4. It says the veins in a leaf form a pair of supplementary angles. So take a moment and say, okay, well, wait a minute. What does supplementary mean? Do you remember? Okay, so supplementary angles are angles that add up to 180 degrees. Okay, so I'm just going to make a little note here, 180. Okay, supplementary 180. I don't know what happened to my red here, but I have to grab another one. Okay, so supplementary is 180. Okay. Find the measure of the angles when measure of angle 1 is 7x plus 13 and 2 is 25x plus 7. So our setup here is that 7x plus 13 equals, nope, not equals, plus 25x plus 7 equals 180. So we're adding the 2 angle measures up, setting it equal to 180. We've worked out a bunch of problems like this last time where we have to find x first, and then we'll plug in x here and here to figure out the measure of these 2 angle measures. Let's combine our like terms. 7x plus 25x is going to be 32x, like the Sega system. That's a dated reference. Some of y'all get that. Plus 20 is 180. Okay. We're going to subtract 20 from both sides and get 32x equals 160, and then divide both sides by 32, and we get x equals 5. Now that's not really going to answer our question here. They didn't ask for x. It asked for the measure of the two angles. So, but we know an expression for each angle measure. Okay, so measure of angle 1, I'm going to say the measure of angle 1, which is 7x plus 13, is going to be 7 times 5 plus 13. This is something you could put in the calculator. 7 times 5 is 35, plus 13 is going to be 48. So this is going to the measure of angle 1 is going to be 48 degrees. Oh, that is not a box. Okay, let's try that again. All right, there we go. Well, not really good. There we go. All right, so that's measure of angle 1. So let's now compute the measure of angle 2. Now, angle 2 is 25x plus 7. So it'd be 25 times x, which we found is 5, plus 7. Now, 25 times 5 is, what was that, 125, plus 7 would be 132. Now, you always want to go back and just double check to make sure that your angles are supplementary. Like if you solve this correctly, they should add up to 180. So let's just double check that in the calculator real quick. Shouldn't take long. So 48 plus 132, are those in fact supplementary? And yes, they are. Okay, so we're in good business here. So there you go. So we found the measure of both angles. And that's going to be how you approach a problem like this. You just have to know that what supplementary means is that you're going to add these two together and set them equal to 180. All right, we've got a few more examples here. This is it. So what? 1, 2, 3, 4. So let's look at number 5. Give me two angles, UVW and XYZ are complementary. Okay, so what I do when I don't remember what this word means is I just go back to my notes and say, okay, what does complementary mean? It means they add up to 90. Okay, so I'm going to make a little note just so I don't forget it as I'm setting up this problem. Okay, so complementary adds up to 90. Okay, just a little note here for myself. And so we want to find the measure of each angle. So we're going to take this same basic approach. I wish there was more room to work here because look how much space this one took up. We'll try, you know what I could do is just make the text a little smaller, I guess. Hopefully that shows up on the video, okay? But we're going to approach it the same way, okay? We're going to set these two, we're going to add these two together, set it equal to 90, solve the equation for x, and then plug it back into each of these to get the two angle measures. So that's the overall strategy here, and that's going to be basically our overall strategy for most of these. Is to set up an equation, solve for x, and then go back and figure out our angle measures. So let's see here. We've got x minus 10 plus 4x minus 10 equals 90. Okay, x plus 4x is 5x, and negative 10 minus 10 is negative 20. Let's move this out of the way. We can add 20 to both sides to get 5x equals 110, and then divide both sides by 5 to get 22. So x is 22, and we can use that to find the measure of each of these two angles. So the measure of, I'm going to steal this little symbol, the measure of angle UVW equals x minus 10. So 22 minus 10 is going to be, well, 12. You probably don't need to calculate for that one. 12 degrees. Okay, so that's UVW. XYZ, the measure of angle XYZ, is 4x minus 10. So 4 times, what was x? Hold on, 22. Okay, so 22, forgot my little equal sign here, minus 10. So 4 times 22 would be 88, minus 10 would be 78 degrees. So we found the measure of both angles here. So you can see this process, you know, we did a lot of these in our last lesson where we just basically set up an equation, solve for x, and then find the angles individually. We're going to keep doing that over and over again. So 6 is set up in basically the same way, except they're supplementary. So we've already done a few problems like this. Remember, the supplementary means they add up to, oh, that is not a line. Okay, there we go. Supplementary means that they add up to 180. So I'm just going to make a little note, 180. Okay. So they add up to 180. So we're going to set it up exactly like this. In fact, just to kind of really hammer this home, I'm just going to copy. Oh, okay. What just happened there? There we go. This copy paste is getting out of control. Okay, so here we go. So I'm going to basically copy my work over here because it's going to be very similar here. And just to kind of make this a little easier to read, I'm going to make a little line here. Okay, so here I want them to add up to 180. So that's what I need to change with this. I got the 3x plus 17 plus 1/2 x minus 5 equals 180. Okay. Now 3x plus 1/2 x is going to be 3.5x. And then 17 minus 5 is 12, so this should be plus 12 equals 180. I'm going to subtract 12 from either side. So 180 minus 12 is 168. And then if I divide both sides by 3.5, I get 48. So notice how the structure of this is identical to what we did over here. The numbers were different, obviously, but as far as the steps we took to get x, we did the same thing over here. Now, to find these other two angle measures, oh, I lost the measure over here. How did that happen? Oh, that's strange. Let me throw that back in there. Did I not? Maybe I never typed it. That's certainly possible as well. In fact, I probably didn't type it because why would I delete like half of it? I don't know. That's strange. All right. Well, no big deal. Okay. So over here we need the measure of EFG, and let's fix this up. Wait, what? What happened here? I think I might have deleted like the wrong. Maybe I deleted the wrong equation here. So that's not what it was. That copy and paste just got out of hand. So the 4 times, okay, sorry y'all. Let's clean this back up. Okay, that's really what it should have looked like. The 4x minus 10. Okay, so yeah, I think that's what happened is that when I did that huge copy and paste, I must have deleted the wrong one. That's my bad. Okay, so now we're back on track here. So we got EFG and we got LMN. Okay, so EFG is 3x plus 17, so that would be 3 times 48 plus 17. We're falling off the page here. This is, okay, we're probably, you know what I'll do? I'll just bring this down a little bit, I think. Might be the way to go. Okay, so 3 times 48, let's pull up the calculator. I'm not really sure what that is. 3 times 48. So 3 times 48 plus 17 is going to be 161. So this is equals to 161 degrees. And then for the LMN, that's half x. So that's 1/2 times 48 minus 5. So half of 48 is 24. 24 minus 5 is 19. So this should be 19 degrees. You can go back and check and say, hey, does 161 plus 19 equal 180? And it does. So we should have a pretty high degree of confidence we got that right. So here's EFG, here's LMN, and you can see the structure of how we solved this was pretty much the same as what we did over here. Okay, so yeah, the overall strategy, just to kind of, I know I've said this over and over again, but we set up an equation, solve for x, and plug that into each angle's expression. We've got 2 last problems here. The first one says, number 7, the measure of an angle is 6 less than the measure of its complement. Okay, so we've got 2 angle measures where one is 6 less than the complement. So if the complement is x, then the other one would be 6 less than that, right? So x minus 6. So in other words, like here's the first one, here's the second one, and if they're complements, they should add up to 90. Make a sketch. Okay, well, it's going to be kind of hard to make a sketch. You know they're going to be pretty close. So like the angle measures should be like, you know, if they were exactly the same, they'd be 45. So we want to make them kind of looking almost like 45-degree angle measures here. So we'll make the bigger one x. And this is just a rough sketch to kind of get an idea. And then, So actually, you know what we could do to really make this look nice is, since we know they add up to 90, why don't we make them adjacent angles, and we know what a right angle looks like. So I think that might be a more useful diagram here. So I'm gonna make a right angle. So here's my right angle. So we know that these are gonna add up to 90, and then I'm gonna draw one more line here. So 45 degree would be here, but we know they differ by 6, so I'm gonna make it a little bit off. Okay, here's the smaller one down here. It's gonna be the x minus 6, and I'm using a protractor or anything. I'm just kind of estimating. And so my x is gonna be the bigger one. So I'll say this is x, and I'll say this one down here is x minus 6. And so we know they add up to 90 because they're gonna make a right angle here. That's not a minus. There we go. Okay, so they add up to 90, and now to find the measure of each angle. Okay, so we need to know what x is to be able to do that, and we're going to kind of follow our what we did up here. So x plus x is 2x. To get 2x minus 6 is 90. Subtract, or add 6 to both sides, and we get 2x equals 96. So x is 48. Okay, so that means that one of the angle measures is 48, the bigger one. Okay, so that means this angle measure is 48 degrees. And if this one is x minus 6, so we got to subtract 6 from that, you get 42. And we can see pretty easily that these are going to add up to 90. So here's the 48 degree angle measure. Here is the 42. So this is the x, this is the x minus 6. Okay, now if we really want to show that this is a right angle, one thing we can do is draw a little box right here to show that that's a right angle. Okay, last question, and then we're done. Okay, two angles form a linear pair. Okay, so again, a linear pair is two supplementary adjacent angles. So let's sketch at least a line out, and we'll see how much bigger one is than the other. So one measure, the measure of one angle is 1.5 times the measure of the other angle. So we've got a bigger angle and a smaller angle. So I'm just going to do something like this and say, if the smaller angle is x, then the bigger angle is going to be 1.5 times that. So if this is x, then 1.5 times x would be like 1.5 times x. Okay, make a sketch. Okay, we got that. And write and solve an equation to find the measure of each angle. So kind of the same thing we did up here, except instead of them adding up to 90, since they're a linear pair, they're going to add up to 180. So we've got x plus 1.5x equals 180. 1 plus 1.5 is 2.5. So we've got 2.5x equals 180. And if we divide both sides by 2.5, we get x equals, what would that be? 108. I'm using the calculator off screen here. Okay, so 108. So that means one of our angle measures is oh, wait a minute. The bigger one's 1.5x. Does that seem right? No. X is not 108. Gosh. 72. Good. Okay. It's like, wait a minute. That can't be right. Okay, so 72 is the measure of the smaller angle. So we got 72 degrees is this one. And then to calculate this one, it's 1.5 times x. So go ahead and just bring up the calculator here. So we got 1.5 times x, which is 72. And that's the 108. So I was getting a little ahead of myself there. So that's 108, 108 degrees. All right, well, that kind of wraps up today's lesson. We talked about, last time we talked about different kinds of angles, like acute angles, obtuse angles, right angles, all that good stuff. We talked about what it means to be congruent. We talked about really what an angle was. And so today what we did was just kind of talk more about angle measures, and specifically we went over all these different terms and what they mean. Okay, so we really just focused more so on the vocabulary here. What does it mean for two angles to be complementary, to be supplementary, meaning they add up to 90 or 180 respectively. We talked about what it means to be adjacent, meaning they share a side and they share a vertex. And we talked about a linear pair and what vertical angles are. So that wraps up today. Hope you guys enjoyed the lesson. Y'all have a great day, and I'll see you guys next time.